And in this video lesson, I am going to show how to solve a trig equation as following. We have a sine of 3 theta equals a negative 1/2. And given that our theta, once solved, we're only taking theta in the restriction interval from 0 to 2 pi. So we want to solve, once again, we want to solve this equation, this trig equation. And of course, we solve our variable in this equation here is theta, so we solve for theta. But given that theta is being restricted in that interval, and be aware that this same exact kind of problem might be worded slightly differently depending on different problems here and there, but the main idea now is that we have a trig equation to solve for, and of course we solve for the main variable here, and the variable is being restricted in a given interval of theta. And this is a quite standard practice in a lot of solving problems, in a lot of solving trig equations in trigonometry. And before I proceed even any further, let me point out a generality regarding this kind of equation. So I did mention that before anyone can view my content of the video lesson here, you must master how to solve this general equation, this very basic equation, sine of one single angle theta to equals a value. And given that the angle from the basic equation is in an interval, say an interval from 0 to 2 pi, an interval from 0 to pi, the generality in this equation we're solving is that we're looking at the kind of generality we're looking at in our equation here compared with the basic standard equation we've solved is that this equation we have is also on a trig function, the standard trig function, either sine or cosine. The angle theta, some variable is being involved. It could be x, it could be y. But the idea now is that instead of the standard version, the standard basic equation, where coefficient in front of the variable is only a single, it's a coefficient 1 in front of the variable, here we're looking at some coefficient a. And so the generality I would like to point out is our equation here is in that class of having a trig function, where our variable here has a coefficient other than 1, and of course equals to a value k. But in this kind of problem, we still want to give the restriction interval where theta itself, the variable itself, is being restricted in an interval, some interval. Here I'm making it up as a, say, 0 to 2 pi right out from the problem here. So the restriction interval is only for the variable itself. We got some restriction interval for theta. So that's some generality I need to point out before we proceed into really solving this equation. And once again, before I move on to the next step where I need to return to the clean board, I want everybody who views this video have a close look in terms of how related these two equations are. The trick here is to see 3 theta or 5 theta or any a theta as one angle. And what I mean is we can, and it's always a good practice to use a temporary variable to substitute for the entire expression inside of your trig function. It could be a cosine function here as well. So here I'm going to let a temporary variable to equal 3 theta. Consequently, the equation will become sine of capital X equals negative 1/2. And this is where it makes sense that I require any viewer who views this video of mine to know how to solve this very basic equation, because the point is we already brought our slightly more complicated equation back into that very basic form right here. So now into solving this, at least in one complete rotation, this equation produces two solutions. One of them is capital X equals 7 theta, 7 pi over 6, and capital X equals 11 pi over 6. And so now at this point, I recommend let's start putting back the substitution expression of 3 theta into our found value for capital X right here. Now keep in mind, capital X is not our solution to the equation here yet. It's only what we found for capital X, and that's why we should go back and representing capital X as 3 theta. So right from here, 3x equals 7 pi over 6 is the same saying as 3 theta has been found to be 7 pi over 6. And same way here, 3 theta, this little other equation means 3 theta equals 11 pi over 6. Reason I'm doing this, I just want to ensure to every viewer that we have not found the solution for theta yet. We only found the solution for what should equal 3 theta and what else should equal 3 theta. Now, one more thing to keep in mind, that the two values we have found here that are equal to 3 theta are only in one rotation. Now, so here there's the second thing to keep in mind, to be watching out for. From the beginning, our angle theta is being given in the restriction interval from 0 to 2 pi. So this is our restriction interval for theta once we solve our equation successfully. Algebraically, theta in the interval from 0 to 2 pi means as an inequality anywhere greater than or equal to 0 and strictly less than 2 pi. And that is indicating one rotation, one complete cycle of our angle theta. But what we have done here in our current step of solving the equation, we found these are in one complete rotation again, but for 3 theta. Or for now, we're treating 3 theta as our temporary variable for now. So 3 theta is our current expression. So that means the restriction interval now, if I think about if we multiply 3 throughout all 3 sides of this 3-sided inequality, then we're looking at the expression 3 theta has a longer interval. If we multiply 3 positive 3 to theta, then we also need to multiply positive 3 to 0, which becomes 0. We also need to multiply 3 to 2 pi, and I shouldn't have the equal sign there. That now becomes 6 pi. What this means is that what we found here is not enough, because we only found the two values of 3 theta within the rotation of 3 theta from 0 to 2 pi. But now we need to find those other values of 3 theta so that they're all being inside of this longer interval, being from 0 to 6 pi. And that's the point. So now in a cleaner space here that I have to redesign my board, then after noting that we have found two values for 3 theta, so on one hand 3 theta equals 7 pi over 6, this 3 theta can also equal to 11 pi over 6. But keep in mind again, this is for 3 theta being in the first rotation from 0 to 2 pi. And so the next step I'm doing now is that 7 pi over 6 simply being added with a 2 pi rotation. So 3 pi 3 theta can be also equal to 7 pi over 6, but plus with a complete 2 pi rotation. Because adding a 2 pi to 7 pi over 6 is going to give us in another value of 3 theta that's still inside of this restriction interval for 3 theta, which is now consequently 3 theta equals 19 pi over 6. Similarly, I can do this same thing for this. 3 theta equals 11 pi over 6. So that is only one value that where 3 theta is inside of the first rotation. I'm going to write for the next solution, I am going to add a 2 pi to 11 pi over 6. And so consequently, I am coming out with 23 theta, 23 pi over 6, I mean. And so now these two other values, so far we have produced 4 different solutions. The first pair of solutions here, the first 2 values belong to the first rotation of our angle 3 theta. That is why 3 theta is here indicated to be in between 0 and 2 pi. These 2 new values we just now found is to indicate where 3 theta is in between, anywhere between 2 pi and 4 pi. The next complete rotation after 0 to 2 pi. And so now once we've gone through this step right here, then we can have one more, because our interval restriction for 3 theta is from 0 to 6 pi. So we can produce one more pair of value coming out of this. So same trick right here. From that interval to get to the next interval, then all you do is just add to every value here, add a 2 pi to every value here. So in my next equation, I am going to produce, so now I can start picking up the pace here, but 19 pi over 6 add with another additional 2 pi is going to give me a 31 pi over 6. And the next value here for 3 theta is from where 23 pi over 6 is. I am going to add another 2 pi, and that gives me 35 pi over 6. And these 2 new solutions which just came out indicate that these are the values where 3 theta is in interval between 4 pi and 6 pi. So really what we have come up to, as for 3 theta being in the restriction interval from 0 to anywhere less than 6 pi, then we actually have found 6 different values for 3 theta. We found 3 theta equals 7 pi over 6. We have found 3 theta equals 11 pi over 6. We have also found 3 theta can equal 19 pi over 6. And we can find 3 theta can equal 23 pi over 6. And we also found 3 theta can equal 31 pi over 6, and we also found out that 3 theta can also equal 35 pi over 6. So we ended up with 6 different values for 3 theta, because these are all the values that we can find being for where 3 theta being inside of that interval from 0 to 6 pi. But then now the 6 values we have found, even though I only wrote down 4 here simply because I'm short of board space, and in my next step I'm going to also write down the other 2 remaining values. But these values, these 6 values together with the one I haven't written down yet, are the values for 3 theta. They are not our solution yet. They're only equal to 3 theta. 11 pi over 6 equals 3 theta. And these values are all together being in the restriction interval, once again I remind, from for 3 theta being anywhere from 0 to 6 pi. So now our solution is coming close. To find the actual value of theta, we now just simply divide both sides of that little equation here. Basically we have 6 little equations, And each of these equations is a 3 theta equals a value, 3 theta equals a value. So now I'm simply just dividing 3 from both sides of my first little equation here. That means consequently I'm going to end up with theta equals 7 pi over 18. This next value, 11 pi over 6 equals 3 theta, produces for us, again, another sub-little equation, sub-equation. It reads 3 theta, 3 times theta equals 11 pi over 6. So we can just quickly or simply solve for theta from there by dividing both sides by 3. And so consequently, again, I'm going to end up with theta equals 11 pi over 18. This third equation of ours, now we can just simply divide by 3 from both sides. We're ending up with theta equals 19 pi over 18. And the fourth equation here is reading 3 theta equals a different value, 23 pi over 6. We can now solve for theta by dividing both sides by 3. And now theta equals 23 pi over 6. And as I said earlier, I was earlier short in space, but now I still have a little bit of space remain. So the other two values for 3 theta that I didn't write down earlier was 3 theta can also equals 31 pi over 6. And so dividing both sides of 3 theta equals 31 pi over 6 by 3, I'm leading to another equation. Theta can also equals 31 pi over 18. And our last equation, 3 theta was also equal to 35 pi over 6. And so once again, solving this value, this little equation for theta value, we're looking at theta equals 35 pi over 18, and allow me to skip the explanation of the step here because I believe any viewer have seen this long enough. And so now what we found here are 6 different values of theta. The last responsibility to do now is to look back at our interval of restriction. Now any of these values right here, we need to ensure that they're all being inside of that restriction interval. If any of these values are being outside of that restriction interval, then we're going to take them out. And so the first solution we have found being the 7 pi over 18. 7 pi over 18 is well inside of that interval from 0 to 2 pi, and you can check me by using a calculator. So this value passed. The next value we found, 11 pi over 18, and you can see that the similarity between the two problems here is that we have the coefficient in the numerator is being less value than the coefficient being in the denominator. So mathematically, I can quickly check that these are all being less than a pi value right there. So 7 pi over 18 is for sure less than pi, less than 1 pi. 11 pi over 18 is also less than 1 pi right here. So these, and being less than 1 pi will for sure guarantee that these two values fall inside of that restriction interval. So this next value, once again, let's confirm right here, 19 pi over 18, and calculation can come out for us that this is also being inside, because 19 over 18 is almost just a little bit over 1 like this, so just slightly over 1 pi, and so it still for sure belongs to that interval from 0 to 2 pi. Now I must correct that this value has been wrong the whole time. It should have been 23 pi over 18. And so theta equals 23 pi over 18 is also another value being inside of our restriction interval from between 0 to 2 pi. Because obviously 23 pi over 18 is still less than 2 pi. Because the ratio 23 over 18 is still less than 2. So any of these two values are still being inside of the 0 to 2 pi angle. And our next one here is theta equals 31 pi over 18. And again, 31 over 18, it needs to be 36 over 18 in order to be equals exact 2. So here we're only looking at 31 pi over 18. That means we're still less than 2 pi. And so this value of theta also passes to be inside of that restriction interval. And our last value here is saying that 35 pi over 18. But as I briefly said earlier, it needs to be 36 over 18 in order to be equals to a 2. And so 35 pi over 18 is still below 2 pi. So this last value also qualifies to be inside of that restriction interval we're looking at. So now our final concluded solution, we have found theta equals 7 pi over 18, that's one of them. Theta equals 11 pi over 18. Theta also equals 19 pi over 18. Theta can also equals 23 pi over 18, where I made a mistake that 23 pi over 6 for a little while, but it's supposedly 23 pi over 18. And we found another solution, 31 pi, typo again, 1 pi over 18, and here 35 pi over 18. So these are all, this is our complete solution set of this equation where theta is restricted inside an interval from 0 to 2 pi. And so now, as a concluded generality about this class of equation in trig, then generally how do we solve that class of equation? Well, what equation was that? The equation here, it could be a sine or a cosine. And what we have here, so here I'm using sine value, but it works the same way. It has the same generality when it's a cosine function. But what we have here is a value, let's say, I'm going to call that some ax. So x is our main variable, and the form here is that we got the trig function, and inside of that it's a coefficient ax, a with the variable, and that equals a constant k. And furthermore, we want to solve this equation for x being inside of an interval between, let's say, anywhere from an interval from c to d. This is the low end and this is the high end of your interval value. But so we want to solve this equation under that restriction, that we want our final solution to be only inside of that interval. So there are two key steps throughout my detailed solution that you have seen, that everybody has seen just earlier. The first key step is to write from this basic equation we are solving for. We have to first we solve for ax. We solve for ax as one variable. And so ax can be equal to some value, say m1, ax can be equal to some value m2, and so on and so on. We can find as many. So how do we know we have found enough? The next key step here, another trick here, is that from our restriction interval right here, then generally, well, then algebraically, it means x is being between c and d, algebraically. Then, but for our current step right here, since we're solving for the values of ax, then that means all we do is now we need to come up with a different, we need to adjust our interval so that it contains the values of ax. So ax here needs to be simply multiply that value, that coefficient a, throughout all sides of our three-sided inequality. So here we're looking at AC, meaning the product of AC and the product of AD. And so here AX, to find out all values of AX here, and we need to extend the interval from C to D to the interval from AC to AD here. And once we have found all that, then the next step, on each of these little equations, say AX equals M1, we are going to divide both sides there by A. Then AX equals M2, we are going to divide both sides by A, and so on and so on. And that's how we produce for ourselves all the different solutions to that equation, sine or cosine of AX equals a value K here. And once again, this generality also works if your function was a cosine function. And allow me to add one more little note here, and I don't have to solve it all the way through, but say, what if we have, like I say, a sine of a minus 4 theta equals to a square root 2 over 2. It's still that same generality as we have solved through the problems earlier in the example. But what's really trouble for us here, seems like a trouble, is the negative 4. Because in my example, in my worked through example, then we usually had a positive value here, which is common to understand for everybody. We work better with positive number. So here, having a negative coefficient in front of your theta, the only trick we need to add on top of that before we proceed solving is to remind yourself that sine is an odd function. So meaning when you're taking sine value of a negative expression, I say that this is a negative expression, an expression with a negative sign, an expression with a negative sign. Then what we can do here is to take advantage on that property of being an odd function. So sine being an odd function, sine on an expression with a negative can be done similarly as sine of the positive expression, but now we leave the negative sign in front. Meaning, this equation can simply be rewritten as sine of 4 theta. But what's going to happen to the negative sign? It's going to become in front. And that equals square root 2 over 2. And this will slightly change our equation a little bit. That means we now, our really final equation to solve for is the sine of 4 theta equals a negative square root 2 over 2. And so now here's where we're successfully landing back into the form where the way the work and the steps will work out just like how you have seen in the earlier part of this video in the example where I showed all the detailed steps. And similarly, in the same additional note I'm making here, what if we have a cosine and again a negative, let's say 5 theta equals to a negative 1/2. I'm trying to be as random as possible, but the main thing here I want to point out is what if we have a negative expression inside an expression with a negative sign inside of our trig function. Then here the only thing we need to work around a little bit, the only workaround being introduced here is that remind yourself that cosine is an even function, meaning when we're taking cosine of a negative expression or the expression with a negative sign, then being even, cosine allows you to completely skip the negative sign. So in other words, cosine of negative theta will equal value with cosine of theta without a negative inside. So it's making things even easier for us. So on the left hand side here, at first it looks a little trouble with that negative 5. But now as we recall from the property of being an even function, then our left hand side simply becomes a cosine of 5 theta. and equals negative 1/2, positive 1/2, whatever value here, we're simply treating that as a value k to the right-hand side of our standard equation. And now we can take these steps to solve it similar to how I have done that in the example.